Now let us look at the next problem. The figure shows a system consisting of, first, a ring of outer radius 3r rolling clockwise without slipping on the horizontal surface with angular speed omega, and an inner disk of radius 2r rotating anti-clockwise with angular speed omega by 2. Okay, so this inner disk is rotating with angular speed omega by 2 with respect to the outer ring, and the outer ring is rolling with angular speed omega in the clockwise direction. Now the ring and disk, they are separated by frictionless ball bearing. So these are frictionless ball bearings. The system is in the XZ plane. The point P on the inner disk is at a distance r from the origin, where OP makes an angle of 30 degree with the horizontal. Then with respect to the horizontal surface, we have to find out which of the following options is or are correct. Okay, you can have more than one option correct. Now since this point P is moving or rotating with respect to the outer ring, so it has got a tangential speed with respect to point O. This speed will be equal to omega r by 2. Okay, because angular speed is omega by 2 times r, which is the distance from the point O, will give you the tangential speed vt. Okay, now this is the velocity with respect to point O. So if we write this velocity in the vector form, this can be written as okay, if this angle is 30, then this angle will be 60. So if we take the component, we will have VPO cos 60 I cap with a minus sign because it is in the negative x direction, plus VPO sin 60 k cap because it is in the positive z direction. Now the value of VPO is omega r by 2 and cos 60 is half. So this can be written as omega r by 2 into half I cap, this is with a minus sign, plus omega r by 2 sin 60 is root 3 by 2 k cap. So the speed is minus omega r by 4 I cap plus root 3 by 4 omega r k cap. This is the speed of point P with respect to O. Also the outer ring is rolling in the forward direction. Therefore the speed of point O or the velocity of point O will be in the x direction, and the magnitude will be given by omega times 3r because the radius is 3r. So the speed is 3 omega r, but this is in the x direction. So velocity of point O can be written as omega r I cap. Now velocity of point P with respect to O can be written as Vp minus Vo. Okay, so velocity of point P will be equal to velocity of Po plus Vo. Okay, so velocity of point P now can be written as omega r by 4 I cap with a minus sign plus root 3 by 4 omega r k cap plus 3 omega r I cap. Okay, now this I cap, the coefficients can be added up. So this is 3 omega r minus omega r by 4 I cap plus root 3 by 4 omega r k cap. This can be further written into as 11 by 4 omega r I cap plus root 3 by 4 omega r k cap. So this is the velocity of point P with respect to the ground. Now let us look at the options. The point O has a linear velocity 3 r omega I cap. This is correct. The point P has a linear velocity of 11 by 4 omega r I cap plus root 3 by 4 omega r k cap. So both option A and B are correct. C and D, they are incorrect.